All right, we're going to start off by going over number 20. We're choosing this one because it's involving the theorems that we learned yesterday. 2, because it's a missing diagram proof, and a lot of you have expressed to me that you want to have more practice on these types of problems. So it's a good way to start our problem today. After I'm done, make sure you have your questions ready. We'll take questions on section 7.1. And if you have questions on 7.2, we can take those as well. So it says, prove that if the midpoints of a quadrilateral are joined in order, the figure is a parallelogram. This is mind-blowing to me. We've already talked about this once, but we weren't able to prove it. Now we can prove it. Okay? Before, I shouldn't say that. Before, we proved it with a coordinate proof. I don't know if you guys remember this or not. But we have any random quadrilateral. Trying to make it so it's not a trapezoid. It's just a general quad. It is irregular, that is correct. So we'll call it Q, U, A, D. Okay? Now we got to create some midpoints. We'll do that. Oh dear, somebody changed my colors again. Do that in red. So somebody get ready to give me a 4-letter word that doesn't have Q, U, A, or D, or repeat. Allie? Does that work? It's got 2 L and an A. It doesn't work. So does Alex. Oh dear. Nike it is. Alright, that works. Alright, so we should use Aves. I've used it before, but not enough this year. Aves it is. Okay, so look, this is crazy. No matter what this green figure is, it can be any random quadrilateral. If we know that I, N, E, and K are all midpoints, then this figure I'm about to draw is a parallelogram. So here I'm going to show you, wow, how. So I would like someone to help me with the givens. What are we given? E? Okay, so we got given quadrilateral. I have no idea how to spell this. Quadrilat. Okay, what else we given? Good. N, I, K, and E are midpoints. Is that it? All right. Okay, so what we want to do is draw UD. And my reason would be 2 points determine a line. Okay? Here's the trick. What does that make segment IN from yesterday? Someone other than Yi. Quinn? I know you do. You're doing great. Quinn? That's right. The midline of which triangle? QUD. Does everybody see that? QN is now the midline of triangle QUD. What other midline do you see? Jody? KE is the midline of what triangle? Okay, so check this out. Now we're going to say that QN, comma, KE are midlines. They call them midlines or mid-segments. They call them mid-segments, don't they? They call it midline. It's different in the other book. Sorry, the Geometry Honors book. QN. No. Oh, yeah. It should be IN. Thank you. I see exactly what you're saying now, guys. Thank you, Nitin. IN and KE are midlines. We've never used that in a proof, so what do you think the reason is? Quinn? That's right. What is the definition of a midline? If what, Quinn? Put it in if-then form. Well, we're going to want to say then it's a midline, because it's the definition of it. I think that is a property of midlines. The definition of midline is, Jody? Yeah. If a segment joins the midpoints of two sides of a triangle, then it's a midline. Okay? That's the definition of midline. Now we're going to use some properties of midlines. So I'm going to say that IN and KE are 1/2 of what? Of UD. And then I think I would just put that in if-then form. If midline, then half base. I kind of made that up, but it works. And you guys are going to have to start doing that because we have so many theorems. You're just going to have to go with it and trust yourself. Okay? There might be a better way to write that, but if you wrote that on a proof, I would understand that you knew what you meant. Okay? Excellent, Nitin. So now I'm going to say that actually, give me one more step. Now I'm going to say IN is congruent to KE. Again, this is a good exercise for you guys just to practice what the reasons would be. So what would that reason be? Excellent, Meredith. That's division. If you called it multiplication, you'd also be correct. We're either dividing it by 2 or we're multiplying it by 1/2. Okay? So segment division. Okay? Now Nitin is right. We will say that IN and KE are what? Parallel. We can't say they're parallel to each other yet, but what can we say? They're parallel to UD. And again, I don't know. We've never said this before in a proof, so we kind of figure out how to say it. If it's a midline, then parallel to the base. Okay? I can now say that IN is parallel to KE. And that's the transitive property of parallel lines. And tell me why I'm done. Yee? Okay. NIKE is a p-gram. And why? Well said, Yee. If a quadrilateral contains a pair of segments that are both parallel and congruent. So I just mark it like this and like that. Then it's a p-gram. Jane, did I mess something up? Okay, what's up? Totally fine. Yeah, totally fine. Totally fine. Jazz? Okay, so if you have a triangle, okay, here's what a midline is. if you connect, what did I just make those? Those blue points are what? But what are the blue points? What are these points called based on how I marked this diagram? Those are midpoints. So if I find two midpoints on a triangle and I connect them with each other, that line that we create is called a midline. That's the definition of a midline. Okay? Oh, geez. All right. So now I know that segment VG must be parallel to ES and must be half of ES. That's what we learned yesterday. That's the important fact of the day. Absolutely. So now, like, if you don't see that it's a midline, I just don't think your mind is allowing you to just look at this part of the picture. Think of it like a kite. You see it now? Okay, good. What else? Homework questions. Anything from 7-1? Yes, Alex. 16, thank you. All right, this is a weird problem with a weird picture. But it's a fair test question, Alex. It just involves a word that we don't use very often, okay? So, it says that it's an isosceles triangle with AB congruent to AC. It's got this D placed in here. It looks like it's a little off. And we are given that angle A equals 30. CD bisects, so these are congruent to each other like this. And then it says BD is one of the trisectors. That's what made this problem difficult, maybe. When we have trisectors, let's try this. What it really means is there's another one in there too. It's just not pictured. So those segments cut angle B into 3 equal angles. Okay? So, I'll mark that like this. 1, 2, 3. Okay? And we are asked to find the measure of angle D. So we're trying to find this. Okay, so we know that this is 30, and it's an isosceles triangle. So these big angles, these big red angles would be what? 75. Good. Okay, well, that tells us that this is half of 75. So is that 37.5? Did I do that right? Okay. Well, this is a third of 75. So that makes that 25, right? So then I would say that x plus 25 plus 37.5 equals 180. And what do you end up getting? Interesting. I'm very interested by it. When I look at my book, there's 2 answers for this. Anybody know why there's 2? Hannah? Hold on. First of all, what do we get when we subtracted 180 minus these? 117.5? I'm so interested by why there's 2 answers for this now. All right, Hannah, tell me. Oh, that's so good. That's so good. All right, this is awesome. Well, that was really well explained, Hannah. I'm proud of you. So here's what she said. It says that BD is one of the trisectors. I assumed it to be the first one, if you will. But you see this dotted one? What if it was that dotted one? Well, then our picture would look like this. If I just drew BDC out of this, we still have, this is what we're looking for, X. C hasn't changed. It's still 37.5. But now it becomes 50. Awesome. You see that? And so if you interpreted it as the other one, then you'd have to set up this same equation. But now say X plus 50 plus 37.5 equals 180. So take 25 away from that, and you end up getting 92.5. Awesome. What number was that? That was number 16. Okay? That was awesome. Didn't? Right. No, I don't think so, because the reason there are two answers is because the ambiguity of the words. You guys know what that word means, ambiguity? It means the language provided there to be two correct answers, because the problem wasn't specific enough, although it was a good problem. It just means we could take two answers. Now, if on a test we ever had a question that was geometrically based, but it involved x squared, that's your indication that there's going to be two answers. And then you'd have to put them both, provided that they were both positive and less than 180 for talking about angles. Okay? What else? This is a good start. You guys are doing well. This is like a kind of a hard couple of weeks, but it's really important because this is virtually the end of the quarter for you. Because when you come back, we have a week and a half and we review for the exam for most of it. So you don't have a lot of grades. I'll tell you about Park. We're going to try to use a piece of software to both get us ready for our exam and to learn how to use software on a math test. The Park test you guys will be taking, it will count for you. You'll take two of them in math alone. You're going to be way over tested if you want my take on it. You're going to be taking two Park tests in math. I think you'll be taking two Park tests in English. Okay? And then you'll also be taking a whole lot of other end-of-course exams. But anyway, the Park test has some really hard geometry on it that I'm not afraid of at all because this class is really hard. But you have to manipulate things on a computer. Like you have to use a protractor on a computer. And we haven't done things like that. So I have to teach you how to do it. And that's, if you looked ahead, that's what that Park review means. Okay? All right, I'm going to pause this, and we'll get started on today's